Now let us look at the topic downstream processing. So after a fermentation process is completed inside a bioreactor, what do you expect to be present inside the bioreactor? Obviously, there'll be the media that was given. The soluble and the insoluble component of the media will be there. The product that has been formed will be there in the bioreactor, but the product will be at a very low concentration because there is thousands of liters of volume inside the bioreactor, of which only a very minute percentage will be the product of interest. The microorganism that was used will be present in the bioreactor. Whatever microorganism you have used to produce your product will be there, the intact microorganism, and some microorganism during the process it might get broken down, and these microorganisms cell components will be there. And we know that when an organism is using up the media, it is growing, it will not only produce the product of our interest, it will produce other metabolites, other metabolic products produced by the microorganism. Even this will be present in the bioreactor. So after a process is complete, what is our aim? We want just our product. Okay, so we'll have to recover a product from this mixture. So how we recover the product, it will depend on different criteria, like where is the product present? Is it present inside the cell? Is it present outside the cell? Like, is it an extracellular or an intracellular component of the cell? What is the concentration of the product present inside the cell? Like, is it at a very low concentration? If it is at a very, very low concentration, you will have to have specialized technique to recover this product. What is the physical and chemical property of the desired product? Can you precipitate it easily? Is it soluble in water? Like certain chemicals and physical properties, you can look at the product, and based on the physical and chemical property, you can devise certain recovery procedures. What is the intended use of the product? Should the product be used as a food? If it is used as a food, how can you recover it such that minimal chemicals are present on the product, or there is minimal toxic material? There is no like, is the product used as a vaccine? If it is used as a vaccine also, it should be maintained at a high purity. Is it an animal feed? If it is an animal feed, you need not make it so pure. So what are the impurities in the fermenter broth? Depending on this also, the recovery process will be different. What is the minimal acceptable purity of the product? Some product should be marketed at a very high purity, 99% pure crystalline substance should be marketed. So what is the acceptable purity? The market price, the magnitude of biohazard, depending on all this, the recovery process of the product will be different. And depending on this, you will be taking out your product from the mixture that is earlier explained. So the various procedures that are involved in the recovery of the useful product after the fermentation or any other process together, all these processes together constitute downstream processing. So downstream processing is very important in the manufacture of different products in pharmaceutical industry, like antibiotic, hormones, antibodies, vaccine, enzyme. After the production of anything in the food industry also, downstream processing should be done. Even when you're producing wine, wine requires certain downstream process. It might not be very elaborate, just a filtration, separation of the yeast component, filtration, and some maybe pasteurization. These are the downstream processing if needed. Okay, you're producing some vaccine, the downstream processing will be entirely different. Removal of the cell, purification by techniques like chromatography, then maybe a filtration using membrane filters, sterilization if it is there, crystallization if it is an antibiotic. So depending on your product, the downstream processing which you are doing to get your product and to market it will vary. So the product, where will the product be present after the process is completed? The product can be present inside the cell or in the medium, or some products will be present intracellularly and extracellularly. Okay, and we should always remember that right after the process is completed, the concentration of the product is very, very low. Okay, So in these cases, uh, it will be there. It will be mixed with other molecules also. So it has to be separated. The cell has to be broken open. The separation of the molecule from other molecules should be done. So everything comes under downstream processing. So looking at downstream processing, it has certain steps. Okay, and always remember, all the downstream processing need not follow every steps described here. Some might require one or two of the steps. Some might require all the steps. Okay, and we can see it. If the product is an intracellular product, the very first step will be breaking open the cell. Okay, and removing the product outside. Okay, but if it is an extracellular product, the cell disruption process can be bypassed. So either way, the very first step after cell disruption is removal of insoluble. You'll be having the media plus the cell debris plus the product plus so many other things. So the very first step is removal of insoluble, separation of solid liquid. Okay, and this can be done with different techniques like centrifugation, flocculation, flotation, sedimentation, etc. After removal of insoluble, you'll get a liquid media or liquid which is having your product of interest but at a very low concentration. So the next aim is to increase the concentration of the product or else decrease the amount of water present. So this particular process can be called as isolation or as concentration. You can also call it as concentration because you're concentrating your product. Again, there are different approaches for which you can use adsorption, evaporation, extraction, precipitation, etc. You can see that many processes like filtration, it can come in removal of insoluble, it can come in concentration, it can come in purification. So each technique is not just under one process. You can use it for multitude of processes. After you concentrate your product, now you want to separate what? Those components which share similarity to the product. You want to purify just your product. Okay, so then you go for the purification process, which can be by mostly it is done by chromatography, then precipitation, etc. And after you get your pure concentrated product, you want to crystallize it, dry it, and package it. So that is called as a finishing, so that you can uh, sell it or you can take it to the market. We'll see each one. So the first step is removal of insoluble, removal of the solid particles. The solid particles mainly will be the cell debris and other particulate matter. And there are different approaches. You can use filtration, centrifugation, sedimentation, flocculation, gravity settling. Okay, so what is flotation? Flotation means you are separating the cell and the solid particles like protein, colloids, etc. from the liquid. So how you separate here is by a technique called flotation. You are making something to float on top of the liquid. So how you do it is you'll add air bubble. You'll introduce gas into the system, and the introduction of the gas will cause the formation of foam or bubbling will happen. And these bubbles or these foam will have the solid material absorbed onto the foam. Okay, and this foam with the solid material can be skimmed out easily because of the difference in uh, the it will be because it is present on the top. So how to make the foam or to make the bubbles more stable, you can add surfactants like long chain fatty acid, amines, quaternary ammonium compound, etc., which is forming a stable form. And these, whatever is added, is called as a collector. And the material which you are making surface active to remove is called the collagens, and these material that are made surface active will be present on the bubble, and the bubbles and the foams are skimmed out, leaving behind only the liquid media plus your product. Then there is a method called flocculation where you are forcing the solid material to sediment. Okay, you are making it to not to sediment, to settle down. So you'll be adding some organic solvent, polyethylene glycol, some acid or bases, etc., so that there is a precipitation of the solid material. Why? Because when you're adding these solvents or acids or bases, there's a change in the property of solid such that the solid which was mixed will become heavier and it will settle down. Then you have sedimentation, where you are settling down the solid by keeping it undisturbed for hours. This is a long process. This is time consuming. So the only thing that it depends on is gravity. So it is also called as gravity settling. Then you can use centrifugation, whereby you can separate the particle based on the difference in density. Okay, so whatever particle is in the liquid medium, it is taken to the centrifuge. Centrifugal force is applied so that the particles settle down. Okay, you can take like continuous centrifugation can be done or batches can be done, and there are different industrially applicable centrifuge models. These are some of the models, that is tubular bowl centrifuge, disc centrifuge, multi-chamber centrifuge, scroll centrifuge. The scroll centrifuge, it is also called as a decanter. So tubular bowl centrifuge, the very first one, it is a very simple structure. It looks like a big tube through which the fluid having the solid particle goes in, and the full apparatus starts to rotate on its around an axis such that the cells are coming on the sides, and the cells can be easily separated and the clarified fluid is taken out. The disc centrifuge has several zones. This is like the tubular bowl centrifuge, but the disc centrifuge have so many zones for the settlement of particles. So the fluid comes in, centrifugation happens, and in the zone, the cell debris and the solids are separated. And the liquid, the clarified liquid, can be collected. Then you have the multi-chamber centrifuge, where you have different chambers which are connected in a zigzag fashion. You will add in the liquid and centrifugation will happen. So here what happens is, at the periphery the centrifugation force is too high than in the middle. So the smaller solid particles are separated or settled down at the periphery, and the larger one in the middle. Then we have the scroll centrifuge or the decanter. So this is a rotating horizontal bowl. This is a horizontal bowl, and as it keeps on rotating, the solid is separated on the walls and it can be scraped out. Now we will have to look at filtration. Filtration is also a method by you can separate the solid particle from the liquid, and the suspended particle can be removed using different sized filters. Like depending on the size of the particle, you can use microfilters, ultrafilters, or hyperfiltration. Okay, and you can remove cells, viruses, different compounds like enzymes, lactose, etc., or sucrose, etc., can be removed here. And these three are the types of filters based on the particle size that can be separated. The efficiency of the filtration also depend on many factors like the size of the organism, the viscosity of the medium, the temperature at which it is operating, etc. And we have several types of filters based on what is the medium or the filter, based on the filter, that is the depth filter. It is composed of filamentous matrix like glass wool or filter paper, and this is mainly used to separate out fungus like. And you have the absolute filter. In this, the pore size of the filters are specific, like you have so this sized pore, it is already uh, pre-sized pores, and you can separate those solid which will not pass through the pore. Then we have membrane filter that can also have a specific pore size, but it is made up of like nitrocellulose or other membrane. So membrane filters can be two types, that is the static filter and the cross flow filter. So in a static filter, what happens is the filtration is done uh, like like this in the first picture. The filtration is done perpendicular to the filter, so there is a chance of clogging of filters. Biomass will clog the filter. So frequent cleaning or frequent replacement of filter is needed. In the next one, that is the cross-flow filtration, the culture solution is pumped parallel to the filter. So hence the clogging of the filter is reduced. Then we have rotary drum vacuum filters. It is used for separating broth containing 10 to 40% of solids, like high percentage of solid. So here, film cells like yeast, filamentous fungi, etc., can be removed. So it is very easy to operate. What is present here is it has a rotating drum. So the tank, the rotating drum is placed inside a tank which have the liquid plus the solid that has to be separated. As the drum rotates, it takes with it some amount of liquid, and when it goes up, the water is removed. Okay, dewatering happens, and the solid particles, it will dry on the surface of the drum, and it forms a solid cake. This cake can be easily scraped out, and like with continuous rotating, what is happening, more and more solid particle can be removed. So if the product is an intracellular component, before the separation of solid and the liquid, the cell has to be disrupted. So if the cell disruption, it can take place by physical, chemical, or enzymatic method. So after the cell disruption is there, solid liquid separation, which was earlier explained, can happen. So release of intracellular product by cell disruption. So various products like vitamins and enzymes are present inside the cell. So these has to be released before it can be isolated and recovered, purified. So the microorganism should be broken or disintegrated by using different techniques like physical, chemical, and enzymatic methods. And which method you will use depend on the type of product you are isolating. Okay, the product should be stable after your disintegration of cell. So depending on your product, its stability, you will use whichever method. So there is physical methods which include ultrasonication, osmotic shock, heat shock, high pressure homogenization, impingement, grinding with glass beads, chemical methods using alkalis, organic solvent detergents, and enzymatic method using lysozymes or glucanase, mannase, and proteases. These are the different approaches to break open the cell. So looking at the filtration physical method, ultrasonication means you are using sound waves. Okay, ultrasound waves are used, but these are not used at the industrial level. Then osmotic shock, you will transfer the bacteria from one medium which is having a different osmotic condition, like 20 percentage of sucrose, and you transfer the bacteria that is present in 20 percentage sucrose suddenly into a 0 percentage sucrose or plain water. So the bacteria is facing an osmotic shock. Okay, there's a difference in the osmotic pressure, and what happens, the cell membrane breaks open. Then you can also give heat shock or thermolysis by subjecting the bacteria or yeast to heat. This is easy and cheap, but you can use this for taking out this products which are heat labile. Then high pressure homogenization is there. In this technique, what happens is you uh, release the liquid suspension from a tank through a very small opening or an orifice. So when the liquid is coming out, there is a sudden change in the atmospheric pressure. Okay, the sudden release in high pressure creates a break in the cell. Then we have a technique called impingement. Impingement, in this, what you do is you will force the liquid containing the bacterial or the fungal cell on such that it hits the surface. So this hitting, this impingement, the process of impingement breaks open the cell. You can either hit the uh, stream of suspended cell onto a static surface, a stationary surface, or you can hit it onto a second stream of suspended cell. Either way, you can break open the cell. This is successfully used in breaking open E. coli. Then grinding with glass bead is another technique. So it is subjected to this is inside a reaction vessel which will be having glass beads, and the cell is ground. So there are several factors that influence the cell breaking. That is the quantity of glass beads used, the concentration and the age of the cell, the temperature, the agitator speed, etc. So under optimal condition, you can expect the breakage up to 80% of the cell. So there is chemical method for disruption. You can use alkalis, organic solvents or detergents. So alkali can be used, but the product, whichever you are extracting, should be stable in high pH or alkaline pH. Okay. One example is recombinant growth hormone can be released from E. coli by the treatment with sodium hydroxide at the pH of level. Organic solvents like methanol, ethanol, isopropanol, and butanol or toluene can be frequently used. Has been frequently used to break open this phospholipid, dissolved phospholipid on the cell membrane. Then you can use ionic or non-ionic detergents. Ionic detergents are CTAB and SDS, which can denature the membrane protein and open the cell. The non-ionic detergents like Triton X100, Tween 20, etc. are less reactive than the ionic one. These can also be used to disrupt the cell. Then you have enzymatic method by using certain enzymes that can act on the cell membrane and open the cell. Like you can use lysozyme. Okay, lysozyme can be used which hydrolyzes the beta 1,4 glycosidic bonds in the bacterial cell wall. And you can also go for glucanases, mannase, protease, etc. Then like you can go for a combination of method where you can use a combination of enzymatic, chemical and physical method to successfully break open the cell. After breaking open the cell, the next step after breaking open and separating the solid liquid, okay, solid liquid separation, the next step is concentration or isolation. So the filtrate, whatever filtrate you have got by removing the solid substance, this is having what, 90 up to 98 percentage water. So there is too much of water and a very low concentration of the desired product. Now you'll have to concentrate your product. For this, you can use technique like evaporation, liquid-liquid extraction, membrane filtration, precipitation, and absorption. Okay, you can use either one, you can use combination also. So which procedure you are using will depend on the nature of your product and the cost factor. So you can use evaporation method where water can be removed by the process of evaporation, and you can do the evaporation in apparatus called evaporator, which is having a heating device for the supply of steam and a unit for the separation of the concentrated product and the vapor. Okay, so there are different types of evaporator. Plate evaporator is there where the liquid, whichever has to be concentrated, flows on this plate system. There will be so many plates and the steam is supplied. So as this it is heating up, the water in the liquid is evaporated, it goes out and concentration of the product happens. Then we have the falling film evaporator. Here the liquid flows down through long tubes, okay, and it uh, get deposited. The product get deposited as a thin film over the heating surface. The heating surface here is the walls of the tube. Okay, so where you can have two models of falling film evaporators, like liquid can be sent in and the vapor can go down through the below, or the vapor can be, vapor means the vapor formed from the water that was evaporated. The vapor can escape from the top. Then we have the forced film evaporator. Here it is just like the falling film evaporator, but the liquid is mechanically driven into the device. Okay, so this is more efficient than the falling film evaporator. Then another one is the centrifugal forced film evaporators. Then we have liquid extraction. So here concentration of the product can be achieved by transferring the product from one liquid phase, like you'll be having your product in a liquid phase. Okay, from this liquid phase, you can transfer the product into another liquid phase. So this can concentrate your product, this transfer procedure. Okay, and that means it depends on the partition coefficient. So the solute will become more concentrated. You can use organic solvent for liquid extraction if your product is lipophilic, and you can extract it easily. But if you're extracting protein, you cannot use organic solvent for this because protein will lose their biological activity in organic solvent. So when you're extracting protein, concentrating protein by liquid extraction, whatever liquid you'll be using will be a aqueous phase. Okay, you'll be separating into our next aqueous phase. Then membrane filtration can be done. Membrane filter is a very common technique for separation of biomolecule and also for the concentration of the fluid. Okay, you'll be using semi-permeable membrane that retains the particle that you want. So the membrane pores will be bigger. And your particle will be bigger than the pores, while the smaller molecules and the water will pass through the membrane pore. The membranes can be made of materials like poly either sulfone and polyvinyl difluoride. Then you have something called a membrane adsorber. So these membrane filter will also have an ion exchange group or an affinity ligand on the filter. So what happens is whatever protein you're separating, it will get adsorbed onto the filter. Okay, and after the process is completed, you can easily elute it out. Then there is a technique called pervaporation. Pervaporation, that is evaporation plus filtration. So this is used to separate volatile substance. Okay, but it is not possible on a large scale. So what happens is you want to separate a volatile substance, you can pass the media through the membrane filter and volatile substances will be evaporated. Okay, then we have post-traction, that is membrane filtration plus solvent extraction, which is used to extract hydrophobic compound, hydrophobic. Okay, then we have precipitation technique, whereby you can concentrate the micromolecule using certain compounds like organic solvent, polyethylene glycol, change in temperature and pH, etc. Then adsorption is another technique where you'll adsorb the needed thing onto a solid adsorbing particle like activated charcoal or cellulose based adsorbent. So after the particles are adsorbed, the water molecule can be removed. After concentration, the next step is product purification. There will be some contaminants which will be very closely related in physical and chemical properties to the product of our interest. So these also should be removed. So product purification is a very selective process, and this is slightly expensive, and it will require more sensitive and sophisticated techniques. Okay, so since this purification is very expensive, not all the downstream processing goes through product purification. Only certain materials which need to be purified, depending on its price, depending on its intended use, it will go through the purification, because significant fraction of the entire downstream processing expenditure goes to the purification step. Okay, so what are the different technique by which you can do purification? By affinity, size exclusion, reverse phase chromatography. Different techniques of chromatography is routinely used. Crystallization and fractional precipitation are also used. The most dependent one is chromatography. Okay, the biological product of fermentation are effectively purified by chromatography. Okay, so very closely related compounds can be separated from a mixture. So we know the principle of chromatography. It has a stationary and a mobile phase. Okay, the stationary phase will be packed inside a column, and the mixture of the compound which has to be separated will be loaded into the column. As the mixture is passing by, Depending on what type of column you are having, affinity chromatography, ion exchange, the compounds will be stuck onto the column. Okay, and the column is then eluted using mobile phase, and finally you will separate out your product. There are different types of chromatography like gel filtration chromatography, ion exchange chromatography, affinity chromatography, each which is based on different properties of the molecule to be separated. So ion exchange chromatography, here you will be using charged stationary phase to separate charged compounds. So you'll be using the property of the positively or negatively charged ion. The resins will be carrying the resins on the chromatography will be having the charged functional group which will interact with the oppositely charged group of the compound. So it will, as the mixture is flowing down, the resin will attract the compound of your interest, and everything other molecules which are having different charge will flow out. Finally, you can elute out your product. Then we have affinity chromatography, which separates molecule based on its affinity to certain compound. For example, you can have if you want to separate a particular antibody, you'll be having the antigen specific to the antibody attached to the beads. This is very, very selective. And the protein of interest can be finally after the separation, the elution mobile phase is run. Finally, all the interesting like protein of interest will be attached to the column, and this can be washed and eluted out. Then we have the size exclusion chromatography or gel permeation technique where the separation is based on the size of the molecule to be separated. So depending on our size, we know the retention time in the column and we can easily separate out. The final stage is the formulation. So formulation means where we'll be maintaining the activity and uh, storing the product. We'll have to uh, finally crystallize the product. We'll have to purify the product. We'll have to maintain its activity such that we can pack it and sell it or take it to the market. So, your removal of water is one technique of formulation. You'll remove the complete water in the product such that it is dried. So, dried product will be active, but it won't get bad very easily. With low water content, the activity can be maintained. So that can be a formulating step, but some molecules you'll have to crystallize it by adding salts or some other techniques have to be used. So in cases, you can also add stabilizing additives to increase the shelf life. Like the protein formulation can be it can include sugar like sucrose and lactose, or sodium chloride, ammonium sulfate, or polyethylene glycol, etc. These additives will stabilize the protein and the protein's shelf life will be increased. Crystallization. Crystallization can be done where you will be forming solid crystal by precipitating the product from the solution. Okay. Then drying. Drying is a technique where you're removing all the water. So you can use techniques like spray drying. So you will use this process only when the product is stable at the temperature that you are using. If it is heat labile, you will use a very, very low temperature for drying. So spray drying means it is a technique where you will be using large volume of liquid. You will be spraying it as small droplet, and it will be passing through a stream of hot gas. This hot gas will evaporate the water in the droplets, and the solid particles will be left behind. Then you have freeze drying or lyophilization. This is a preferred method because you don't go for high temperature, and this does not cause any loss in biological activity of the desired product. And this process lyophilization is also called as freeze drying. It is based on the principle of sublimation. So these are all downstream processing, just know that not all step of the downstream processing have to be followed for every product. The different steps, some product will only need one or two of the downstream processing, some might need more product or combination, more methods or combinations of methods. So that is all.